So good evening my dear students. Today we will discuss about the determinant and their important properties. Yes, in this lecture also I will solve some important questions and I will discuss various properties. That properties will be helpful for you. Okay. And here also I will discuss about some conditions under which this determinant is exist. Yes, and after that I will discuss here the application of determinant. Yes, okay. So guys, what is determinant? Basically what happen, for every square matrix we can find a number or we can find an expression. Yes, for any square matrix we can associate a number, and actually that numbers or the expression is called here the determinant of that matrix. Okay, so guys, the definition of the determinant here: every square matrix A can be associated to a number or an expression is called here determinant. So one thing you have to remember here we consider a matrix, suppose this one, 1 2 3 4. So obviously this is a square matrix of order 2. Then for this matrix we can easily associate, we can easily find a number. Yes, or we can relate this matrix with a number, and that number actually is called determinant. And consider A is a matrix. This is a square matrix. Yes, square matrix. Then the determinant of this A we denote by this way. Yes, or sometimes we denote like this way. Now guys, 1 by 1. Yes, जब एक मैट्रिक्स का ऑर्डर 1 होता है, then what will be the determinant of that matrix? So suppose we consider a matrix A and whose element is this one, only 1. That means the matrix is 1 by 1 order. Then what will be the determinant? Determinant of A will be this one, that elements will be there. Yes, only one elements will be there. जो element रहेगा वही होगा determinant. So another matrix, suppose B of order 1, suppose 2. Then what will be the determinant of this B? This will be 2 here. Yes, so this is 2. So this is simply the determinant of a matrix with order 1. Okay, now comes 2 by 2 matrix. Then what will be the determinant? That means what will be the number or expression? Yes, which is associated to this square matrix. So suppose we consider the matrix is A11, A12, A21, A22. So here we consider the general matrix of order 2. Then what will be the determinant? So determinant of A will be this one. Yes, A11, A12, A21, A22. Now what will be the value of this determinant? Then what we do guys here, just you take the product of these two one and this two one. So first you take this product, then what will be the value? A11, A22, and what will be the product of this two one? We'll get here A12, A21. Now you subtract this value, this one. You see here again, I repeat here, this the product of this one minus a product of this one. So this is an expression on, or if you consider this A1, A11, A12, A21, A22 are some numbers, then this value obviously will be a number. Yes, so this is the determinant of this one. Yes, so here again I will consider another matrix whose entries are some number. Suppose we consider a B matrix, suppose whose elements are 0, 4, 1. Suppose this is the matrix. So what will be the determinant of this B? So this will be 2, 0, 4, 1. Yes, so if we take the, or if you use these properties, then what you do, just you take the product of this one. So 2 into 1 minus 4 into 0. So this will be 2 minus of 0, that means 2. This 2 is the determinant of this matrix B. Yes, that means 2 is a number which is associated to this matrix. So that is, this 2 is nothing, the determinant of this matrix. Okay, similarly, so this is our matrix. Then what will be the determinant of this matrix? Yes, so just you put all the entries here first. So A21, A22, A23, yes, A31, A32, A33. First of all, what we do here, just to choose or select any rows or any column. So here I consider here the first row. Then what happened at the first element of this first row? So what is the first element of this first row? This is A11. Then what will be here? Just you put here A11. Then just you delete all those elements which are in these rows and these columns. You delete all those elements. ठीक है, ये एलिमेंट जो रॉ और जो कॉलम में है उसको पूरा पहले डिलीट करो. डिलीट करने से जो एलिमेंट्स रहेगा यही को लेके एक 2x2 डिटर्मिनेंट बनाओ. देखो हाउ मेनी एलिमेंट्स आर देयर? देयर आर 4 एलिमेंट्स. सो ऑब्वियसली वी कैन कंस्ट्रक्ट ए सब मैट्रिक्स ऑफ ऑर्डर 2x2. यस. सो फर्स्ट ऑफ ऑल व्हाट वी डू, हम लोग जो एलिमेंट्स को हम लोग चूज करेगा वो जो रॉस में है और जो कॉलम में है उसको डिलीट करो, बाकी को ले लेना है. ठीक है, तो इसका साथ क्या करना है, देखो इसको डिलीट कर दिया तो क्या रहेगा, ये चारों रहेगा. सो यू कंस्ट्रक्ट द मैट्रिक्स डिटर्मिनेंट हियर A22, A23, A32, A33. yes. Similarly, choose the second element of this row. So that this is the second element A12. Again, you delete all these elements in these columns and in this row. You delete this row and column. So here you see these two and these two. These 4 elements will be there. So here will be A of 21, A of 23, yes, A31. A33. And then similarly you take these last elements here also, this one. Then again you delete this column and this row. So these 4 elements will be there. Now you take the determinant of them. Yes, so here will be A of 13 and you take determinant. So this will be A of 21, A22, A31, A32. Bas. Yes. And after that you see again I repeat this thing here, just you have to choose the any row or any columns of that determinant. And here I consider the first row, and here what you do here, just you consider the first element of the first row and you delete this row, these columns and this row first of all. Yes. And you take the determinant of the remaining elements. So these 4 elements will be remain here. So this will be the first determinant. And similarly you choose the second element here. Again you delete this one and this one. If you delete this one, then here will be 2 elements, here will be 2 elements. So you take the determinant with using these 4 elements. So this one will get here. And similarly you choose the last element here and you delete this one. So here will be these 4 elements. So you construct the determinant here. Yes, sorry, here this is okay. Now after that what you do here, just you put here minus symbol and then plus. Okay, that means क्या होता है, ये जो फर्स्ट एलिमेंट्स के लिए होता है ना, इसको प्लस में रखो एंड देन सेकेंड के लिए जो जाएगा उसको माइनस करो एंड थर्ड में जो होगा उसको प्लस करना है. बस इतना है. ठीक है, प्लस माइनस प्लस, you remember this thing, plus minus plus. Now you can easily find this value, find the value of this determinant. This will be this one into this one minus this one into this one. Similarly you can find that value of this determinant. Yes, इसका साथ इसको multiple करो, minus इसका साथ इसको करो. Similarly you can also find the value of this determinant. Yes, so now you find all these determinants and you put right this. Yes, so what will be the value here? You see A11, इसका साथ इसको करने से क्या होगा, A22 A33 माइनस A of 23 A of 32. Yes, and then minus you put here minus A of 12, here A21 A33 A21 A33 minus A22 A31 A23 A31. Yes, and then here you put here plus a of 1 3, and then again you find the determinant of this one. This will be a of 2 1, a of 3 2, minus of a of 3 1, a of 2 2. Yes, so this is the value of this determinant. Yes, so now if we consider that some numerical value or numerical entries, then you obviously you will get a number here. Yes, so this number is nothing but determinant of this 3 by 3 matrix. Okay, and during your calculation you may skip this step. Yes, you can easily skip this step. How your calculation or simplification, you can skip this second step. Yes, you can skip this one. Directly you can write this one from this one. Then what we do here, directly here, so first you choose the first element and you delete this one and this one. So these 4 elements will be there. A22 देखो, A22, A33 minus A23, A32. Yes, similarly you put here minus, क्योंकि first plus है तो minus होगा, and then A12 इसको बैठाओ तो E और इसको cancel करने से क्या होगा देखो. Now these 4 elements will be there. Yes, these 4 elements will be there. ये दोनों. So you take this one and this one. That means A21, A33, A31, A23. Yes, you see here. A21, A33 minus A31, A23. Yes, similarly you put here plus and then you write this one. So इसको delete करने से क्या होगा, A21, A32, A31, A22. इसका साथ ये मल्टीपल करो, इसका साथ ये करो, यहाँ में बैठा दो. So take a numerical example. So I hope it will be easier. So this will be there, this will be there. Yes, so now you take this one into this one, minus of this one into this one. That means 0 into 0 0, minus 9 into 3. Yes, so this way we can easily find. So similarly you choose this element and also you delete this one. So these 4 elements will be there. Yes, so here you take the product of this one and you subtract this one. Similarly you choose this value. Yes, that means these 2 will be cancelled, so these 4 elements will be there. So after that I think you can easily find now. Okay, so what we do here, 0 को ले लो तो क्या होगा देखो, 0 का साथ 0 कितना होगा, 0 into 0 minus 9 into 3. Yes, 9 into 3. माइनस डालना है क्योंकि फास्ट 0 दिया है तो -5 डाल रही है. अभी इसको कैंसिल कर दिया तो क्या होगा, इसका साथ इसको करना है, इसका साथ इसको करना है, तो 0 into 1. Yes, so 1 into 0 minus 0 into 3. So 0 into 3 will be there and then plus ओके कितना है, 2 है, बस रखो. अभी इसके लिए क्या होगा, ये दोनों कैंसिल हो जाएगा, होने से क्या रहेगा, इसका साथ ये, इसका साथ, तो 1 into 9 minus 0 into 0. So 1 into 9 minus 0 into 0. Now you simplify this one. So here you see this will be 0 because 0 का साथ मल्टीपल करने से क्या हो जाता है, 0 हो जाता है. Minus of 5, this is also 0 because here 0 0, so 0 minus 0 means 0. Here you see 2. Now what will be this one, 9 minus 0, so this will be 9. So you see this value will be 0, so 9 into 2 will be 18. So this is the value of this determinant. There are few important properties are there which are related to this determinant. Yes, so guys, you see there are many important properties are there. One is here intersense the two rows. Yes, intersense the any two rows. So suppose we consider a matrix A. So suppose this one, A B C P Q R X Y Z, and suppose we want to intersense these two rows. Yes, that means X Y Z P Q R A B C. Here you see just we intersense the first and third row. Then the determinant of this new matrix, yes, this is our new matrix. So the determinant of new matrix will be, so determinant of this new will be here minus of determinant of the old matrix, so previous matrix A here. Yes, that means if it interchange of any two row, or you can interchange any two columns also, then the value of the determinant of the new matrix will be equal to the minus of the determinant of the previous matrix. Okay, so this is an important properties, you must remember this one. Yes, and another thing you see here, and here you see this thing we write this operation, this R3 R1 को हम लोग R3 से replace कर दिया और interchange किया, this one we write like this, R1 we interchange R1 and R3. Yes, so we write like this. Suppose if we want to interchange the ith and jth row, then we write like this way, this thing we write like this way. Then the new determinant of the new matrix will be minus of the determinant of it. So you must remember these properties. And another properties is there. If we replace Ri by K of Ri, then what happened? The new determinant matrix or determinant of the new matrix will be the K times of the determinant of the original matrix. Yes. So this is an also important properties here. So here you see what we do here. Suppose if we want to do this thing, okay, suppose here I will consider an example first. Suppose here A B C D is a matrix. So suppose this is our old matrix. Then if I take some multiplication, place here twice of R1. Yes, this is our R1, this is our R2. So here I use this property. Yes, I use this property. Then what happened here, you see, if I use this property, then our new matrix will be this one. Matrix will be twice of A, B, C and D. So this will be the new matrix. So now you find the determinant of this new matrix. So what will be the determinant of this matrix, new matrix? You see here, if you find this matrix, so what will be this one? Twice of AD minus twice of BC will be there. You take the product of this one and then you take the difference of this one. So you see this will be, if you can easily take 2 common, so here this will be the determinant of our new matrix. And also you see here what will be the determinant of the previous or original matrix. Here this will be A B C D. So here you take the product AB minus of BC. So you see the determinant of the original matrix is here AD minus BC, and here you see determinant of the new matrix is 2 into AD minus DC. That means from here we can easily write here 2 times of the determinant of the original matrix is nothing, determinant of the new matrix. So properties is there, you see this one. If we use this one, that means Ri we replace here by this one, Ri plus K of Rj. Yes, then the determinant of the new matrix is equal to the original matrix. That means suppose this one, here I will take an example. So suppose our A matrix is this one, A B C D. Yes, this is our matrix. So obviously the determinant of A will be AD minus of BC. Yes. Now you apply this method, this properties on this matrix. Then what will be here? Here R1 suppose we replace R1 plus 3 of R2. Suppose we apply these properties. Then what happened? You see here, if I apply this property, then what will be the new matrix? So new matrix will be here, you see R1 plus 3 into R2, that means 3C plus 3c plus a will be here, and here will be 3 d plus b. Yes, and the c and d will be the remaining. So now you find the determinant of this new matrix. So what will be the determinant of this new one? So this will be 3c plus of a, 3 of d plus of b, c and d. So now we product this one. So 3 of c plus of a into of d minus of 3 of d plus of b into of c. So you take 3cd plus of ad minus here also 3dc minus of bc will be there. So you see this 3cd, this 3dc are the same thing, so these two will be cancelled. So finally also we get here ad minus bc. That means the determinant of it. That means if I apply this rule, then the determinant of the new matrix is nothing equal to the determinant of the previous matrix. Yes, if any row or column of a matrix A is completely identically 0, then determinant of A is 0. So this will be identically 0. That means suppose we consider a matrix, suppose like this one, 1 3 0 2 5 0 0 7 0. So you see in this matrix, this column is nothing, all the elements of these columns are 0. That means the determinant of this matrix will be here 0. So you can easily verify these properties. Another properties are there. If any two rows or columns of a determinant are identical, then the value of the determinant is 0. Yes, this is also important property. This property is this one. Okay, suppose this one 3 5 7 2 0 3 2 3 5. Yes, so the value of this determinant will be 0 because you see the first and third, these two rows are identical. Yes, देखो इसमें क्या है, 2 है, इसमें भी 2 है, here 3, here also 3, here 5, here also 5. That means these two rows are identical. That means value of the determinant will be 0. Yes, you can easily verify. You find the determinant of this one, you will get 0 here. So, and you see another property. This is also here important properties. Here suppose we consider A is a matrix of order n, then determinant of some constant k into A will be k to the power n into determinant of A. Yes, this is an important properties, or you can easily verify these properties. Suppose we consider A is a matrix of like this one. Yes, x y z p q r alpha beta gamma. Suppose this is our A matrix, then what will be the determinant of, suppose 2 to the determinant of twice of A? This will be 2 to the power 3 of determinant of A, determinant of this one. Why? Because our matrix is our 3 by 3 matrix. That's why I put here 2 to the power 3. If we consider here a matrix of order 4 by 4, then this here will be 2 to the power 4. Yes, and you can easily verify this property. So just you take any small matrix with some numerical entries, you can easily verify. And also another property is here, you see determinant of AB is nothing, determinant of A into determinant of B. Yes, so this is important. Determinant of A and the determinant of the transpose of that matrix are kya hai? Equal. That means if we interchange the rows and column of a determinant, then the value of the determinant remains same. Yes, that means suppose we consider the matrix A is nothing, A, B, C, D. You see, what is the determinant of this matrix? This will be A, B, C, D, C, D. So this will be AD minus of BC. So this is the determinant of this A. Now if you find the A transpose, so here the transpose मतलब just you रो को चेंज करना है, कॉलम बनाना है, और ये रो को भी कॉलम बनाओ. So what will be the determinant? What will be the determinant? So determinant of this A transpose will be, here you find this determinant, this is also AD minus of BC will be there. That means you see the determinant of A and determinant of A transpose are क्या है, equal. That means if we interchange the rows and columns of a determinant, then the value of the determinant remain here same. Okay, so you see this is also an important property here. If A is a skew symmetric matrix of odd order, then determinant of A is nothing, 0. Yes, this is most important property. So you see here that A is a skew symmetric matrix of order odd. That means here you see, suppose A is a matrix of order n by n, and here you see A is a skew symmetric matrix. So what will be here? In case of skew symmetric matrix, we know that A transpose equal to minus of A. So just you take that determinant on both sides. What will be this one? So here determinant of A transpose is nothing, determinant of A, already we got from this one. And here you see minus of A matlab minus of 1 into A. So this will be minus of 1 to the power n of determinant of A according to that previous third properties. This one, yes, determinant of Ka is nothing, K to the power on K to the power n into determinant of A. Yes, this will be here. Now you see here, in our case the order is our what? That means here n is odd. So if we put here n is odd, then what happen here? Determinant of A will be here, this will be minus of 1 because n is our what? So and minus 1 to the power any odd number will be here minus 1. So minus of determinant of A will be there. So you take this minus of determinant of A in the left side. So what will be here? This will be 0. So twice of determinant of A will be 0. So here this will imply determinant of A is 0. So this is an important properties, guys. Yes. So you must remember this one. So when this matrix is skew symmetric matrix as well as the order of that matrix is odd, then the determinant will be always 0. Yes, this is a skew symmetric matrix. Already you know this thing, and the order of this matrix is 3 by 3. So determinant of this matrix will be here, guys, 0. Yes, so you find the determinant of this matrix. The determinant of this matrix will be 0. Yes, our matrix is a skew symmetric matrix as well as the order is nothing, what? Yes, so the determinant of this matrix will be 0 here. And here also you see, if A is a orthogonal matrix, then determinant of A will be प्लस माइनस 1, आइदर प्लस होगा और माइनस 1 होगा, ये दोनों में कोई भी एक होगा. सो now you see in case of orthogonal matrix, or when a matrix is called orthogonal, do you know? Only when this is happen, A transpose A equal to identity or A into A transpose. Yes, if this is happened, then we call the matrix is orthogonal. Yes, so now we take the determinant on both sides, then what we get here? So determinant of I. So also you remember this thing, determinant of identity matrix is always on for any order. Yes, so this will be here. So now you see again we have here this properties, determinant of AB is nothing, determinant of A, determinant of B. So you use these properties, then what will be here? Determinant of A transpose, determinant of A equal to 1 here. So determinant of A transpose means determinant of A, and here also you put here determinant of A is 1. So here determinant of A square will be 1, and that means determinant of A will be plus minus of 1 on. Yes, so this is the proof of this property. So this way we can easily prove all the properties. So I think you can easily remember these properties. Yes, so for any orthogonal matrix, the determinant of that matrix will be plus minus 1.